Okay, welcome to this video. We're going to look at, we're going to fill in some brief notes. We've got more that we're going to fill in later with these things. We've got formal definitions coming for a mole and for Avogadro's number, but we're not going to worry about the formal definitions in this video. We'll get those in class. So what is a mole? Just kind of conceptually, you can't, if they ask you for the definition of a mole, what I'm about to write would not be correct. It's not the definition. It's just how we think of it conceptually. A mole is a way of counting what particles or molecules, the number of let's say counting the amount. Let's say we'll just say particles, counting particles, molecules, etc. And another way to say that, it's a way of counting the amount of substance you have. And there's another bullet we're going to get which defines a mole, but don't worry about that yet. Okay, what's Avogadro's number? Again, we'll define it, but just kind of conceptually, well, it's a value which is equal to 6.022 times 10 to the 23. And look at this, if we look in our data booklet, we've got a page that gives us a lot of different constants. Here's the fundamental constants we're given. And let's see, Na, do you see Na anywhere? Here it is, Avogadro's constant. So look, they're giving us the value 6.02 times 10 to the 23 moles to the negative 1. So let's adjust our value. It's 6.02, just 12, times 10 to the 23. And the unit is moles to the negative 1. Okay, and what is it conceptually? This is not our definition, but Avogadro's number is like a dozen. It's a way of counting a very large number of molecules. So what's the relationship between number of moles, the number of elementary entities? Elementary entities, that could be particles, molecules, atoms, particles, molecules, atoms. Anything else like that? So what's the relationship between little n, number of moles, big N, how many you actually have, and Avogadro's number? Well, the answer is, if you take how many you have and you divide by Avogadro's number, then what you're doing is it's like taking 24 donuts I've got 24 donuts, each dot is a donut, and I'm grouping it into dozens, into groups of 12. So I've got one group of 12, two groups of 12. If I divide it into groups of 12, I get how many dozen. The same thing is true here. If you take the number of molecules and you divide it into groups, equal groups, totaling Avogadro's number, you get the number of moles. So here's our equation. Now you can see that N, the unit of N, it's the number of moles. The unit is moles. The MOL stands for moles, not molecules. And let's leave that. And the number for Avogadro's number, the unit for Avogadro's number, as you see, is moles to the negative 1, or 1 over moles. And if you plug in something in 1 over moles, well, the units are going to work out in this equation. And big N, the number of elementary items or entities, the number of particles, atoms, molecules, it has no unit, so we say the unit is just 1. There are no units. What is molar mass? Molar mass. We'll get a definition, but right now let's just do an equation. It's the mass of a substance divided by the number of moles, the amount of the substance. The unit of molar mass is just, well, let's look at the equation. Molar mass is mass over number of moles. So moles is actually the unit itself. Mass is going to be in grams more often than not. So it's going to be grams is what we'll use for mass. Grams per mole. That's the unit for molar mass. So what's the mass of nitrogen-14? Well, the molar mass. When they give you this value at the end, that is actually the molar mass. That's their way of saying the molar mass is 14. So the molar mass for nitrogen is 14 grams per mole. There's another concept, mass density. Mass density gets the variable rho. It looks kind of like a P. It's a Greek letter. And the equation, the density, is the mass per unit volume. Right? So what are the units of mass density? Well, let's look at the equation. The numerator is mass. The units of mass are grams usually. Volume can be measured in milliliters, but instead of measuring in milliliters, we can also measure the volume in liters, so maybe it's going to be grams per liter. But we can also measure volume in cubic meters. Cubic meters, meters cubed, or centimeters cubed, or maybe kilograms per cubic meter. So you have a lot of options. You just need a mass unit in the numerator, which we have in every case, and a unit of volume down in the denominator, which we have.